In this video we're going to look at starting probability, some of the language, some of the questions we might have to answer, and particularly with two different things happening, how many outcomes, etc. So first of all, I've got two unbiased dice, and here's the first bit of language, unbiased. That simply, we might use fair instead of unbiased, but it simply means that the probability of landing here on this dice of a 1 is the same as a 3 or a 6, etc. Now when the blue die is rolled, how many outcomes are there? Outcomes are all the things that could happen. So when I roll the blue dice, it could land on a 1, could land on a 2, could land on a 3, a 4, a 5 or a 6. So in actual fact, we have 6 different outcomes. When both die rolled and the scores are added, how many outcomes are there? We have 6 on the blue dice, and we have another 6 on this dice. Now we don't add these, we actually multiply them together, and you'll find out later anything where you have and in probability is multiply. So 6 with the first dice and 6 outcomes with the second is 36. Now I've just kind of told you there's 36 by timesing these together. Let's have a look at what all 36 outcomes are. And the easiest way to list all my outcomes is to make up a table. So here I've got a table, and here I've got the blue dice from 1 to 6, the red die from 1 to 6, and here these numbers in the white boxes, they are the scores when you add them together. So if I have a 2 here and a 1 here, I get a 3. You can see there's 36 outcomes. One of the things that students often get confused with is that this 3 and this 3, they're the same. But they're not the same. Because to get this 3, you've done it with a red 1 and a blue 2. And to get this 3, you've done it with a red 2 and a blue 1. So even though we have a 5 here, it's a different way of getting it than a 5 here. So there are definitely 36 different outcomes, even if some of the numbers are the same. Now I'm going to look at some probability questions associated with this. So the dice are rolled and the scores are added. Calculate the probability of obtaining a 6. Now before I start, I'm going to put on the bottom of this fraction 36, because there are 36 different numbers to choose from, or it's out of 36. Now here are my 36 choices. All I'm going to do is go around and find the probability of obtaining a 6. And it's so easy if we have a table. So here's a 6. 1, 2, 3, 4, 5. There are 5 different ways of making the 6. Calculate the probability of obtaining a score of more than 6. Now if it says more than 6, we do not include the 6. Everywhere where there's more than 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 times. So there are 21 scores that are greater or more than 6 out of 36. Calculate the probability of obtaining at least. Now this is different from this because we can include the 6s. So we want all of these that are bigger than 6, and we know there's 21 of them already. So we've got 21, 22, 23, 24, 25, 26. So there are 26 that are at least 6, so we're including the 6 in that score. And do you notice I'm not actually going to simplify any of these? If the dice are rolled 36 times, how many times would we expect a score of 6? Now this isn't asking for a probability. Look here, this one's a probability. This one doesn't ask for probability, it's how many times. So if I do it 36 times, which is exactly this time, the number here, how many times would I expect a score of 6? It will be 5. I would expect that to happen 5 times. But not 5 out of 36, because it's not a probability. The dice are rolled 144 times. How many times would we expect a score of at least 6? Now, at least 6 was the probability was 26 out of 36. So I'm going to work this one out by putting the probability down and timesing the probability by the number of times that I rolled a dice, which is why I've got my calculator here. 26 divided by 36, and then I'm going to times it by 144 to get 104. So I'd expect that to happen 104 times. It's not guaranteed to happen, but it's what we expect. So the key words here, the key things to think about: unbiased, outcomes. How are we going to get outcomes when there's two events? We multiply the individual outcomes together. More than at least is a key word here. Make sure that the question is asking you for a probability or is asking you how many times.